Lesson 8. File Processing. This is Dr. Teo Kim Heng. Informatics Academy. Python programmers use lists and dictionaries intensively for storing data. However, such data structures store the data in the main memory, which is volatile and cannot keep the data persistently. In other words, when the computer is turned off, the data stored in the in-memory data structures are purged and lost. In order to keep the data persistently, the data must be stored in non-volatile persistent storage such as hard disks. Files are named containers and persistent storage. Modern operating systems typically group files into folders, or directories, and organize the folders and files in a hierarchical structure. File processing means manipulation of the contents of a file, including creating, reading, updating, and deleting files. File processing is an important part of applications. File processing involves three major steps. Open a file. Manipulate the file using file manipulation operation, search data, insert data, delete data, and update data. Close the file. Open a file. The purpose of open a file is to make the file contents available to the program. Python supports file open operation through the built-in function open, which returns a file handle object that can be used for file manipulation until the file is closed. Internally, the file handle object keeps track of the information critical for file manipulation such as file structure, the current position of the read-write head, buffer, mode, etc. For example, in the following codes. The first line call file open function for reading, specifying a full path name of the file as argument, and store the return file handle in F1. The first line call file open function for appending, as specified in the second argument. The first argument specifies a path relative to the current working folder. Such a path is called a relative path. The open function requires many parameters. All the parameters, except for the file name parameter, are optional. The file name can be a relative path name, which specify a file in the current folder, or a full path name, which specifies the complete path of the file. When opening a file, we can specify the mode to indicate whether we want to read, write, or append to the file and where the file structure is binary, or text file. The default value for mode is reading from a text file. In other words, the default value for the mode is RT. R stands for reading. T stands for text mode. Character encoding. We can specify the character encoding when opening a file. For example, the following statement opens a file in appending mode, using UTF-8 for encoding. UTF-8 is an efficient character encoding scheme, using a variable number of bytes, 8-bit blocks, for encoding different types of characters. It uses 1 byte to encode ASCII English text, uses 2 to encode most commonly used Unicode characters, and 3 to 4 bytes to encode less commonly used Unicode characters. By the way, UTF stands for Unicode Transformation Format. File manipulation. The most common file manipulation operations are: readline, n. Read one line from a file. The parameter, n, specifies the maximum number of characters to be returned to the caller. The function returns the line as a string, capped at n characters, to the caller. By default n equals -1, indicating the all characters are returned as a string. Readlines, n. Read many lines from a file. The parameter, n, specifies the maximum number of lines to be returned to the caller. The function returns the lines, capped at n lines, as a list of strings to the caller. By default n equals -1, indicating that all lines are returned as a list. Write, s. Write a string from s to the file. The parameter, s, specifies the string to be written to the file. Writelines, list of line. Write a list of lines to the file. The parameter, list of line, specifies the list to be written to the file. The following table lists file manipulation operations. Most of the operations are out of scope for this course. Go through the table yourself. Exercise. Study the program. The program opens a file for output. The parameter W for the open function stands for a write mode. The file type is, by default, a text file. The program writes 10 lines of text to the file, using a definite for loop. The program closes the file after the for loop. Note that the range for the loop starts from 1, steps 1, and ends at 11-1, which is 10. Code the program in a Python file. Run the Python file. Verify the contents of the output file. Exercise. Study the program. The program opens a file, using default mode, which means open the file for reading as a text file. The variable, f, holds the file handle of the file. The file handle is an iterable, thus it can be used to control the definite for loop. The program iterates through the line in the file, using a for loop, and prints all lines to the console. The last statement closes the file. Code the program in a Python file. Run the Python file. Verify the output. CSV files. CSV stands for comma-separated values. It is the most commonly used file format. CSV is used as the default import and export format for almost all spreadsheets and database software. Python supports CSV file manipulation through the CSV module. The following exercises demonstrate CSV file manipulation. The program inserts 3 rows of customer data to a list, and write the list of customer data to an output file. I will explain the codes, but you should stop the video and go through the code yourself. The first line imports the module that supports CSV. The second line specifies the output file name. The third line specifies the header of the output file. The fourth defines a list, called customer list, for holding the data in the main memory. The fifth line appends the header as the first row of the customer list. Note that customer list is a list of rows, where each row is a list of 4 strings. The next 3 lines append 3 rows of data into customer list. The following 3 lines display the contents in the customer list. This is achieved by iteration, using a for loop, through the rows in customer list, and print each row in the loop body. The next 4 lines demonstrate standard steps for CSV file output. The first command opens a file for output. The W stands for write. If the file exists, the data will be purged. The second command converts the file handle into a CSV writer. CSV writer can be used to write a list of rows to a file of rows. The third command writes all the rows in the customer list into the customer file. While a normal file handle supports writing a string or multiple strings to a file, a CSV writer supports writing a row through the writeRow function, or writing multiple rows through writeRows function, to a file of rows. Each row is represented in the program as a list. A row is represented in the file as a string, with the components separated by commas. The fourth command closes the customer file. The last line is straightforward. This is the output of the file. Notice that the customer list is a list of rows, represented internally as a list of lists. Check the folder which stores the program source codes. You should be able to file a file named customers.csv. You can open the file using Excel or Notepad. Verify the contents of the CSV files. Study this program. The program demonstrates the steps for data input from a CSV file. The first step is to open a file for input, using R as file mode in the open function. The second step converts the file handle into a CSV reader. A CSV reader is an iterable, so the program uses a for loop, iterating through the rows in the CSV file, and appends each row into the customer list. Finally, the program iterates through the customer list, and print each row to confirm that all data are retrieved. This is the output of the program. You can check that the CSV reader reads all rows that were written by the CSV writer. In the next few slides, we will learn how to program a simple interactive file manipulation program. The pseudocodes of the program look like these. First, the program should display a welcome message. Then it goes into a loop. In the loop body, it displays the menu which displays 6 options for the user to choose from. Then, it reads the user's input option. Based on the input option, it calls an appropriate function to fulfill the service. If the input option is 0, the program terminates. This slide shows the library package and data structure to be used in the program. The first import statement looks strange. The first datetime indicates a module. The second datetime an object defined inside the module. The import statement makes the object available to the subsequent codes. Datetime is used to retrieve the current date and time to form part of the welcome message. The next few lines have been explained in the previous examples. This slide shows the definition of a function that prints the welcome page. It makes use of the following API of the datetime object. Now method for retrieving the current date and time. String format time, to create a formatted string. The %C format code asks for a locale's appropriate date and time representation. The following table shows common date-time format codes. Now.time. Hour to determines whether now is morning time or not. Try to code the function and test to see the welcome message it displays. This slide shows the codes for a simple menu function. The function just prints a multi-line string which explains the options for the user's input. This slide demonstrates the codes for resetting the customer file. This function is meant for testing purposes. A real application should not have this option. This option simply purges all data, if any, in the existing customer file. Then the program inserts some sample customer data into the customer file. Internally, the function calls save customer data to write the customer list to the customer file. This slide shows the codes for data input from the customer file. The code should be familiar to you now, except for the global variable declaration. Without the declaration, the customer list will be local to the function, and have nothing to do with the global customer list defined outside the function. This slide shows the codes for displaying all customers from the customer list. This demonstrates the use of for loop for iterating a list. This slide demonstrates the codes for reading customer data from the console, and appends the data to the customer list. No data validation is performed. So, the program will accept junk data, such as funny phone number. This slide demonstrates writing data to a CSV file through a CSV writer. This function is also called by the resetting function to reset the customer file. This function prints a thank you message when the user enters option 0 to exit from the application. This slide defines a function for getting the correct option from the user. The function uses an infinite loop to ask and get the correct option from the user. It also uses int conversion function to convert the character input to an integer. This is the main function. The function defines a list of service functions corresponding to the input options, and call the service function accordingly. The last line calls the main function which kickstart the whole application. This slide demonstrates the sample run of the application. This is the end of Lesson 8. Thank you for your participation.